Number 18. So we have a PDF, f of x equals 1/10 on 0 to 10, 0 otherwise. And we found the CDF in part A. And that was this piecewise function, 0, 1/10 x, or 1. And we had x less than 0 here, x between 0 and 10, and then when x was larger than 10. Okay. So part B asks, what's the probability of seeing an occurrence of our random variable between 3 and 7? Now, there's a few ways of doing this. Probably the simplest way is, well, what's the shape here? This is a box. What was the height? It was 1/10. So that's the shape here. Remember, it's on in this zone, and then it's off outside here. And the question is asking, what's the chance of seeing between 3 and 7? So 3, 7, want to find that area. Well, what's the width here? That's 7 minus 3 is 4. So this is width 4, and you have height 1/10. So this probability is going to equal the area, which is height times width. You know the height is 1/10. The width is 4, so this is 4/10. Okay, so that's one way to evaluate that. And notice that this didn't involve any integrals. This is just simply a rectangle, and you're just saying, do these bounds line up with this shape? And if they do, what's the area? That's it. You can also use an integral. We have the CDF already, so I'm going to write this in terms of the CDF. So this is another way to do this. So this probability of finding a random variable between 3 and 7 can be expressed as the chance of seeing it less than or equal to 7 minus the chance of seeing it less than or equal to 3. Now, because this is continuous, there's no difference between it being less than or equal to or strictly less than, because the chance of seeing any single value is 0. Okay, so we use our CDF formula. It's this one. So this is 1/10 times 7 minus 1/10 times 3. So 7/10 minus 3/10 gives us 4/10. Okay, and what this computation is doing is it's taking, well, you're using the CDF, but if this is your function, it's taking the area that you want. So you're taking 7, so it's the area of everything this going less than 7 minus the area of everything less than 3. That leaves you with just this piece alone. Okay, and so this type of calculation is one that you do with other distributions. So it's useful to understand how it works.